All right, I finally picked up a couple dimmers for that I thought would be appropriate for running this LED. Um, and I also picked up a few power supplies, LED drivers. This one I've already torn apart. Um, this one is completely potted, and it's an IP67 rating, so it's meant to go pretty much anywhere. You can throw it outside. Um, I think this one was 60 watts. This one was 45. 12 volts. Yeah. Yeah. Meanwhile, anyway, they got some good ratings. Uh, the Meanwhile one was 16 bucks. Um, this dude was 30. It also came with wires, which so you get a plug and you get a little adapter, as well as the $30 one is dimmable, which I don't know. I was just curious. I don't even think I have any dimmers anywhere, um, but maybe we can compare that style of uh, dimming with a triac versus the style of dimming that I've chosen to do, which is just straight up uh, DC. Um, so without further ado, let's tear these guys apart and take a look. Cool. So it doesn't look too bad. Um, Sorry, my lighting isn't that great. That looks like a no-name chip. That's probably the receiver. That's the wireless dude. Just a no-name, I guess like LED controller or something. And some sort of MOSFET. Okay. Anyway, I'm not gonna reverse. Ooh, that there's kind of ugly. Huh. Not. That's not super ideal. Sorry, I'm fiddle fucking with my focusing so much. Anyway, lot less going on in here than I thought. Um, it's just a one-sided circuit board, so there you go. 10K, 470. All right. Okay, I'm gonna try to get through this faster because this is horrible. Um, so the remote's not bad. It's a 433 megahertz remote, and there's the digits off of it. It's got real buttons. Yeah, so it's not a bad little package. Um, I'm talking over myself. Let me turn down this audio. We'll just bust through this because I actually lost audio and I was trying to redo it, and oh my god, what a pain in the ass. So that's one of those weird 12-volt batteries. I don't see them in a lot. Um, I never really found the antenna unless this is it, which it kind of looks like it might be, but maybe it runs to the back side of the board. Um, anyway, nice little remote, I think. It's got this silicone insert. Um, so here, I'm just fiddle fucking with this little electric screwdriver, and it's kind of been weird, but it's neat. Yeah, let's just fast forward. But yeah, a neat little screwdriver. Here we go. Zip, zip. I thought this was just going to be like a resistor in here, but I was pleasantly surprised. It's got TI, like a little timer and a little op amp, um, and then a little MOSFET. And I think we're looking at it right here. Is where we were thinking we could feed that timer with our own PWM or something, to maybe control this thing. Um, I was considering just integrating with it, using a resistor network in place of the pot, just so I could wire in a ESP8266, because they need to be in everything. Um, but yeah, these are all TI components from the looks of it, and it's just a one-sided board. There's the money shot. I don't know what I was droning on against here. I guess sizing your power supply properly. Um, you want wide open, not to be too much. You don't want your LED to be able to draw too much current. I did verify that this actually pulls 12 volts, or excuse me, that supply limits things to 12 volts. I didn't do any short circuiting, but the LED certainly drove it at 12 volts, and that means it's pulling about 2 amps, which is like 25 watts, which is like what I want. Still messing with my electric screwdriver. You get a pretty sweet connector with that thing. This is 20 gauge silicone wire that I'm using. And since I only plan on drawing a couple amps at most, it's actually got a lot of wire in there for being only 20 gauge. So, and then here I'll just back up and let the audio come through, because I think this is all relevant info. Ugh, such a pain in the ass. All right, let's try this. Dim. This is artifacting. Ugh. All right, nothing exploded yet. Here's our light. Ooh. Ooh. So some of this is artifacting from my camera. Um, Yeah. So I don't see too much flicker. This is actually a really pleasant dim light. You can maybe, yeah, see those flicker lines. Um, 60 hertz. MPEG is running at 30 frames a second. uh, Math is hard. Why does it? I used to know a lot about MPEG in my former life, and so I'm just amazed at these artifacts right here. This looks so. Oh, nobody cares, that man. That line is interacting with the. All right, so this is actually representative of what the LED looks like to a human eye at low dimming, and there's really no pulsing or anything. Um, you do end up with like a 2K sound that reverberates with the power supply in this case, but it's really barely audible. Um, and I think later I should explain it, but whatever. This whole setup is pretty silent. Um, Running at different dim levels for long periods of time, nothing got hot except for the LED got hot at full on, which was running it at 24 watts. So it was dissipating quite a bit of heat. Let's see if there's anything else. Encoder. Anyway, yeah. So this is not putting off a lot of light right now. That's also the WDR function of my light. So there's a lot going on here with that weirdness. So I'm just gonna mute the audio again, and let's just peel through here. It's real linear. So I was pretty impressed. Here I actually checked the voltage. I got a new I got a new Cara after watching some of Dave's multimeter reviews. I picked up one of these little dudes because you just can't have too many. And my Fluke is always out in the shop. And anyway, so this is the first time I play with that little dude. We got 12 volts and full tilt. We got 12 volts. So here we're pulling about 2 amps more than likely. So it's a good setup. So let's fast forward. Here I'm playing with my new screwdriver. Oh God, yeah. Here I had lots of scope problems. Here I had a bad ground, and I was chasing. I didn't know what the fuck was going on. And then here, I may have finally gotten it figured out. Nope, still got a bad ground. I was like, why does this look like this? This is wrong. And then, uh, anyway, bad ground. Here I finally fixed the bad ground, and it was right there. And holy shit, I'm pissed off at these probes right now, and I've barely even used them. I've barely even used this scope. So, yeah. So this is the profile. As soon as you dim, this is at low dim. It jumps up to 7 volts, and then the peak is whatever your input voltage is. So I don't really know how this works, how we get our 7 volts at any sustainable current. Like I don't think the op amp in there can push much current at all. Um, I don't know. I don't know how this works, and I'm not gonna reverse engineer the circuit, but I can tell you it didn't really get hot. Um, and this might explain why the pulsing isn't super bad, even though there's absolutely no, big caps or anything that are leveling off the voltage. So, um, so here's full, and then we're dimming down, and then all the way down it just drops to 0. So it's actually not a bad little circuit. And that was 750 hertz. And what's going on here? Yeah, it's all worthless. I think it's talking about integrating, and I think I just want to put something in this box to make it be controllable via wireless. I don't like this other wireless setup. I can't integrate with it. Um, and a friend and I were talking about that, and he basically said, "Oh, you should just build a new entire dimming circuit." And then another friend of mine was like, "Dude, like just use one of these little chips," which hopefully is coming up here. Oh, no. First, I have to talk about how incredibly shitty these connectors are on this guy, and I wouldn't use them for anything. They're just super bad. And then here so the first time I tried to make this video, I actually accidentally put the thing back together upside down. So I plugged up plus to minus and minus to plus. Okay, this is like one of those read the color, not the word or something. Um, where I had plus over here and minus over here, and I plugged it up backwards, and it survived. Well, here I'm plugging the the power into the output, and we're running it backwards. And when I hit the off button, I think it dims a little bit, and then it turns back on, and then it dims a little bit, and then it takes me forever, and I finally realized that I've actually hooked it up backwards. Derp. So I correct that. So anyway, it survived all of that. Um, it had the exact same profile on the scope, even though these chips weren't TI or fake TI chips. Um, Again, you can see the WDR functions of my camera removing some of this light. But this is super bright. Um, One of the other neat features about this little wireless dude is that it maintains state. So if you jerk power, it will come back on in whatever state it was. It doesn't matter if it was off, on, or at some dim level. So they're writing bits every time you click a button. So that's kind of cool. Um, yeah, here I was shorting it out there with my screwdriver. Whatever. Removing power, plugging it back in, showing that it actually went to the same state. And I think I even did that on the scope. Yeah. And here's the profile again. So it looks really, really simple, similar. Let's see if yeah. So here we're going to full cycle. Yeah. So these chips or these two systems are similar. Um, and this is wireless already, and we were talking about maybe integrating to it, but I think this little dude's going to be maybe better for it. And then I don't know what I was rambling on about here. Okay, so taking this thing apart was kind of a bitch. That threw me off. I figured I cut something loose, and I was a little upset with myself because I knew on the other side of that wall was going to be this, something heat sinky and staked to the outside. I didn't know it was going to be isolated, and it looks like it's Loctite. So, I also don't know. I know there's a rectifier right here. I don't know what this other chip is doing. It's probably, perhaps it's a, oh, I said it earlier. the zero crossing uh shoot, what are they called? But the dimmer circuit basically. Um, or maybe the other side has it, but usually it would be on the AC side to interact with any kind of dimmer that's going to notch out the AC signal. So it escapes me what those are called right now. Um, but I try to get what numbers I can. I couldn't really get this thing apart any further, or just didn't want to. And I wasn't sure if this transformer, like, there's not super isolation anywhere along this board. I kind of assumed shit gets rectified, and then I didn't know if part of this transformer was being used like a buck. Um, and then somewhere I said mauve. Uh, what else? Yeah, there I finally discovered that's where the rectifier is. Eh, some chip porn. Eh, the connectors on this thing are really nice. That one isn't quite as nice, but the high side's super nice. Uh, Waiting for the money shot. There you go. There's the money shot on that guy. UTT 36N10L for those chip aficionados. I think I get a money shot on the other. These are all 105-degree caps. Mostly no name. The green ones are berries. I don't know if those are well known or just more no names. Yeah, there's a money shot. YA868615. I don't know what that guy is, to be honest. Maybe he's sensing, uh, or controlling the. Maybe it's he's the volt limiter. I don't know. Um, so yeah, this is that dimmable dude, and there's the beefy connectors on the high side. Those are really beefy and nice. When I first tried to get this thing apart, I was tugging at the sides, and that's just not going to work. And I finally realized that the lid peeled off. For 50 watts or 45 watts, I don't know if those traces they're probably fine. Yeah, so there's that guy. I didn't pull apart the other one because it's potted. And more playing with my electric screwdriver. Don't know what I was talking about here. Uh, oh yeah, I was talking about integrating. So this this microchip chip, I'm hoping it just costs a couple bucks. And if that's the case, then you're looking at, you know, we've got a 1K pot in the manual dimmer circuit, and this can do 257 steps. And I'm assuming, I mean, maybe we can adjust down to a 1K pot and get the full steps, but even if we can't, we can get 50 steps, and that's like plenty for dimming for me. So if these are kind of cheap, I might buy a couple of them because I don't know. I felt like putting one of these on a 8266, maybe it would be a good excuse to roll a board. And then you can just control this with SPI and just act like a trimmer. Um, and that would give you a good easy integration point into a lot of different devices. Like you could even run, those tiny little buck booster regulator things. Like I buy them on eBay all the time. Like you could even wire one of those in to do something, you know. Or build a battery charger that's what am I trying to say? I'm trying to say, yeah, you could just do lots and lots of stuff by by being able to control a circuit like that through a simple integration point and monitor the circuit. You could build something that could profile a battery and charge it, a single cell, but that'd be fun. Um, so yeah, I'm gonna order some of these, and let's see if I bring up anything else. I'm listening to myself. Some of this has audio, so. Oh, so one of the concerns was we looked at, we could have just torn out or we could have just pulsed in the, uh, like ditched the timer chip and pulsed in our own PWM. And, but like I was concerned that by doing that, I might introduce either through my own shitty code or lack of being good at anything, accidental brightness. And it's funny because this little wireless dude does exactly that. I don't think you can see it in the video, but I dim all the way down, and then if I hit dim again, you'll get a burst of light, and um, it's not annoying or anything. It's just interesting. And so the other reason I wanted to kind of use a resistor network to integrate with the dimmer and just act like a pot is because I assume a resistor network device like that would latch. And so once it's latched, you're just going to get whatever that resistance is, which should be like a really stable environment, for the rest of the circuit, which is doing the dimming. And, depending on that for timing, or for the PWM cycle. So, yeah. So basically, don't do as much in the little 8266, and just leave yourself a nice integration point with great big pads, where the pot was. And then, if the 8266 had a analog to digital converter, then you could even reuse that pot and still keep the manual dimming. But I don't think it does, or it's not. I'm not sure if it does, but that would be cool if it did, because then you could just rip out the knob, put in your wireless, put the knob back in, wire it all, just make like a little board. So here I was trying to demonstrate the interrupt and the light, but it didn't work out for me. I don't know what the fuck. So here, this thing is pretty silent. I ran off this supply at first before I took it apart, and at at varying dimming levels, there was a 2 kilohertz sound. And I think I demonstrated it here, or I didn't demonstrate it, but I showed it. I put my phone on the device, and I was able to pick up um, a noise. This is not it, but when I tested it, I definitely saw shit. But again, it wasn't bad. And I think if it were behind anything or under anything, you just wouldn't hear. And my cat didn't hear it or mind it or freak out either. So I don't know what I was blabbing on about here. I have some really high powered garage lights. I considered dimming them, and then I think instead I'll just run secondary lights for when I'm not doing detailed work out in the garage. And then same deal with street lights around my house. I I actually shot them all out, and I've never had street lights out here, but I kind of want them with my new build, and I considered dimming them. So I have a couple examples of streetlights that I'll probably end up using. I think they're 24 volts, and I was also considering running this at 24 volts, and I don't know what that's going to look like, and I haven't tested it. But kind of the same deal. I want to run my lights at a lower. I want to take it easy on whatever LEDs I use because I'm sick of LEDs just breaking. Like normal bulbs and shit, they just break from being overdriven typically. And so, like this giant 70-watt light at 24 watts is going to be a hell of a lot better than a bunch of bulbs running at 7 watts each full tilt. Um, if I ran this at 70 watts, it would probably survive however long an LED bulb survives. But if I run it at 24 watts, then it's likely going to survive a lot longer. Um, in my opinion, LEDs are expensive and bad for the environment. So this is just kind of my way of trying to ensure that if I build something once, I just won't keep having to replace it because all this shit is just going to the landfill. Um, yeah, it's kind of gross. I don't know what I'm talking about here. Outdoor lights again. Those are my garage lights with uh they're just giant heat sinks with 300-watt, you know, lights with lenses on each one. So like they're probably really common drivers and common everything, if they break I can just put in a new LED. So they'll be serviceable forever. Um, but some of these other drivers, which I think, no, that was it. I think we're done. Thanks for watching. I hope you don't mind me talking over myself. It was kind of difficult.